Volker. Thank you, Volker, for being here with us. Welcome.
Thank you very much, Olawale, also for setting this up. And yeah, it was always nice and inspiring meeting you, talking to you about teaching statistics, and welcome everyone online. So I really hope, thank you for joining, first thing. And I really hope that you will learn something and see something different today. Yeah, so I'm sure we all want to learn from data. We want to get insights from data. Data we already have, we have to get or we have to collect ourselves. We want to learn from data, and that's what I want to show you. Hopefully, something new, maybe something also easier, inspiring, and practical learning from data using our software. Jump. It's JMP. We say jump, and I'm with the Jump academic team, so I work for the academic program, and I'm happy to present what we have to offer and what's in for you, hopefully, today. So before I start talking, and I really want to reduce talking today. I really prefer to show you our software in action and not just talk about it. Maybe a good news, I hope so. There are no slides at all, zero PowerPoint today. But to start, I would like to take the first 90 seconds to play a very short video, a demo about the academic software package. And just this shows you already a lot, and I think it sets the stage very nicely. I will play it. I hope you can also understand um, the output. So let's see.
JMP Student Edition is the ideal software for teaching and learning data analytics, statistics, modeling, and design of experiments. Offering all the features of JMP and JMP Pro, it is available for free to faculty, students, and academic researchers at degree-granting institutions, running natively on both Mac and Windows computers. With JMP Student Edition, time stays focused on teaching concepts rather than software syntax. Thanks to its interactive point-and-click interface, students can easily explore everything without the need for programming, from simple ANOVA and regressions to multivariate analysis, from design of experiment to predictive modeling and machine learning methods. The software allows for the creation of clear, reproducible problem-solving workflows, effectively preparing students for professional environments. And since JMP software is an industry standard, using it in university courses helps students develop the practical, high-demand skills that employers are looking for, giving them a competitive edge in the job market. A wide range of free teaching resources such as books, case studies, step-by-step guides, and extensions are available to facilitate the learning process. JMP Student Edition is the tool that connects the classroom to the real world. Request a license now on jump.com/student.
Okay, so that was everything in a nutshell, just 90 seconds. I hope there was something also talking to you. So maybe you saw a cluster analysis, a neural network, some regression, some modeling, profiling. In general, a theme here is really being visual and interactive. Yeah, and I think so from my experience, and I'm with Jump for 15 years now. From my experience, I think it's the most interactive, most accessible software package for analytics. Yeah, and I don't, as I said, I don't really want to talk a lot about it. It's used in industry a lot, but it's also used in higher education and also commercial training courses. Um, so what is the plan today? As Olavale said, it will be an overview today. So really showing you what's in, also a bit getting started, how to use it. And that's maybe the first part of the session today. So this is more getting started. It's also more about the software, but I have to say using the software, learning the software is not a big deal. It should be not a big deal. There's something you should know, but you will see everything during the first demonstration. Yeah, and we will just do some exploratory analysis, visualizations, some basic statistics. Yeah, and that's to get you started and to show you how to run an analysis in JUMP. And then we can have a short discussion, some questions, and then the second part will look into some more advanced methods. It will be more maybe concept related, how to do things, not in the software, but analytically. Some best practices, looking at
Nero
machine learning,
the
also
IPO,
other
DP ano
other.
Nero the IPO on him queen. That he's not ready to continue.
Okay. Yeah, if you could mute yourself, that would help a lot. Um, so I have my speakers open. If there is a question, maybe Ola Wale, you can just let me know. If others have questions, please put them into the chat. Yeah, so we will have um, two two opportunities today to discuss them, and maybe a bit more time for a discussion at the end. And I would also be interested at the end what you think. Yeah, do you think there is some added value? So I know you are already doing analytics, you are using Python and R, and welcome to the club. So there are many other users who are also using other packages. Everyone typically uses also other packages. But it's good to know options, and Jump is pretty complementary and has something else to offer. And it also integrates with Python and R and other software so that you can also use them together, not just alternatively, but also together. So that's setting the stage. Um, as I said, I want to really make it short and come to the software and show the software as soon as possible. By the way, I will also share all the content you see here on the left. This is the so-called Jump Journal. So it can have text and links. And the blue lines, these are links to the internet, web pages, and there are also some data sets embedded. And I will share this one, and there's a second one. I will share the journals I'm using today with you. So with Jump installed, you can also open them and look at them, follow the references, the links, but also open the data sets and do what you will see in a minute. Again, I just keep it short. What is Jump? You already saw the first demo, the video. Just the links we have on the journal. You can also follow later. Yeah, so on our website, jump.com. So there's a section about capabilities, customer stories, the workflow, and all these details. So these are analytical capabilities as you see here. Yeah, so for instance, advanced statistical modeling. Yeah, you see a lot of different methods. What's maybe interesting is some of them have a pro icon. So they are exclusive to our Jump Pro package, which has some additional methods. However, the academic version you get as an academic user also has everything. So you get the Pro package with all the capabilities we have listed here. Scripting, basic analysis, modeling, and so on and so on. So you can just browse those yourself. These are the capabilities supported by our software. If you ask yourself, where's this used? Where's this relevant? It's really relevant in industry because it's a standard package for experimentation, for process optimization, for many um, analytics and statistical methods. And here you see some core industries using our software, and you can also have a look and go into details. So if you're interested in chemicals, see some typical use cases and where JMP is used there. And then some of our customers also created some customer stories with our marketing. So you can also read about these stories. What were the problems? How did they solve their problem using JMP? So here you see all the companies with success stories. There's one I would recommend, Villanova University. That's a university in the US. Yeah, and that's a brand new success story. And this is about a graduate student who got a few days to run a project and present the results. This student was fluent in Python, but he used JMP, and you can read about that story and watch the video. Yeah, and there you will see what happened to that student. So capabilities, customers, success stories, that's there. Let me just move on. Getting JMP, maybe we can also discuss this later. First thing, for academic use, learning, and also academic research, there's a free license. It's called JMP Student Edition. And we also have free codes for continuing education for industry people. So please discuss this with Ola Wale after the session. If you are in industry, if you don't have access to an academic license, we can also arrange for that. And that's everything I want to mention for the beginning. And now let's have a look at the software and some getting started and some sample analyses. Okay, so this button here, open some data. Yeah, so this is a button which has a script, and the script has a data set scripted, which just opens up when I click this button. And also when you click the button, you will see the same data set. And this is the data set here. I just arranged it a bit better for reading. So that's our data table I want to start with. Today, what is it about? This is a process, a chemical process. Yeah, and what we are interested in is the yield. We really want to see a high yield. Yeah, and the yield is a percentage. So it's between 0 and 100%. What we know and what also the software knows is, so here is the column, the yield column. It's a variable, yeah, with all the yield measurements for 90 batches in this data set. Yeah, so we have 90 rows. Each row is one batch, and every batch has a yield measured. That's the outcome. Yeah, and what we want to see is there's a spec limit, so there's a requirement, a specification, and this tells us there's a lower limit of 80. So that means that the yield should be above 80%. Yeah, and the goal of this exercise is to configure the process to set all the parameters so that we maximize the yield. Yeah, so that's the adventure here using this data set. We also have a second response, a second outcome. It's a binary outcome, just was it accepted or rejected? Yeah, and you see everything below 80% was rejected. I can show you this also by opening a preview for the columns, yeah, and then just selecting the rejected batches. Yeah, we see these are the low yield batches. Yeah, all the values are below 80, yeah, and they are all rejected. So that's the story. The process itself, you don't need to understand it. I'm also not a chemist, but just the story is that there is a yield, that's the outcome, and there are many settings. Yeah, so we can choose from different suppliers for carbamate and other ingredients. We have different vessel sizes and vessel types. Yeah, so there are many parameters, many predictors to predict the yield or to explain the yield in the first place. Yeah, and all the predictors, so they are grouped into categorical predictors and continuous numeric settings. Yeah, so here we have temperatures and amount, carbamate amount. Yeah, and categorical is something like vessel size, and vessel sizes are the large one or a medium or a low vessel size. So that's just setting the stage. Uh, a re- just a reminder, if you have a question about this, drop it on the chat and we can come back to this later on. What's special here? So here we have basic navigation. I don't, it's maybe a bit too dry. I don't want to cover all this in theory. You just see it in action. What's special here is this one. So that should be mentioned because in JMP, you start with the data table, and the data table is more like a database. It's a structured data organization. So we have all our variables typically in columns. And here we see this data set has 18 columns. Yeah, and we have all the observations, in this case, batches in rows. Yeah, and if your data set is not like this at the beginning, maybe you have to prepare your data for an analysis, and we have table tools for splitting and stacking and sorting and everything to get the data in shape, and also quality related outliers and missing values. There are also tools to clean up the data set. So this one here, our demo, this is already perfect for the analysis. Maybe not the real case, but let's start and jump in. Everything is ready to analyze. And let's do it. So what I want to show you is how to get started, how to start with such a data set. Let's assume you are a process engineer, maybe, or you are the manager of this manufacturing site, and then you want to understand the problem. You want to understand this data set. Yeah, and the data set is new to you. Yeah, so you're looking at this data set for the first time, and I'm sure you are. I'm not, but you are seeing it for the first time. So how could we start? And there JMP really shines because it's also great for exploratory analysis. Just see what we got here, and let's have some basic analyses and some initial visualizations to check this database. Yeah, so this is not really statistics. It's not, at least not um, hypothesis testing, because maybe we don't have any hypothesis yet. We have to generate hypotheses we want to test later, and for this we have to get an idea about our data set. And that's where you use exploratory tools. And the first one maybe you could use as a first tool, or we say platforms, because they are all, yeah, rich applications. Every platform is a rich application where you can do many different things. And this is the first platform for interactive graphing. So what does this mean? Let me show you an example. So as I said, we are interested in yield. It's drag and drop. So I drag the yield and drop it on the y-axis. First thing, we just get a dot plot. Because we have this spec limit I showed you earlier on yield, JMP also draws this lower spec limit, and then everything above is good, green, and everything below is not accepted, and red. So this is just a dot plot, one dimension. Let's have a second dimension cover made amount. I can also make this bigger here to see more variables. Cover made amount. So if you are wondering, does the yield relate on the cover made amount, just one predictor in our data set? I drag it and drop it on the x-axis, and then we see a scatter plot. Yeah, just by default, JMP activates some graphing elements. And here we have two elements active. We see the dots. That's this one here. It's active and selected, and this is a smoother. Yeah, I can also point to them, and you see this is a smoother element. And for both elements, we also get some settings for fine tuning on the left. So I can fit the smoother more or less to our data. I can also add a confidence band and, yeah, do some fine tunings and some other settings. And now somebody asks, okay, so we see a relationship here. We see a relationship, but is this the same relationship for different vessel sizes? Vessel size is a categorical variable. I take it, and then I can drop it on any blue drop zone. I could drop it here. I just keep the mouse button pressed. I don't drop it yet. I just move it around. So I could wrap, I could just color, I could overlay, and then I say, oh, stop. So drop it. So now vessel size is used as an overlay. So that means we see the relationship by vessel size. So we get basically three different models overlaid. So if I'm done, I would say done. Oops, a misclick. I'm done, and then we get this. What's special is everything is interactive, so that means I can select. Let me just reset this so that we see the whole data table activated. So I can select some data points just by doing a multi-select, and you see that everything is connected. So if I would have multiple graphs, you would see the same selection in all graphs and also in the data table. And it works also the other way. So if I'm on the data table, Yeah, everything unselected, and I start to select some rows. You see it's half hidden, but hopefully you saw that everything is connected. I can also point to a data point, yeah, and see which one this is. I see the values. I can right click here and maybe exclude this point or give it a special marker or color to investigate it later and so on. Yeah, so this is the exploratory process here. I can get the settings back. So now we are looking at regression lines, 3 regression models. And there are many other ways to create graphs. So yield, for instance, yield by vessel size we already used. So now we have yield in 3 different groups. Yeah, so I can also add box plots. Yeah, or I could add a contra plot as well. Yeah, and I can select it, or another one is all the continuous predictors on the x-axis and then use a parallel plot. And then I can, again, each batch has a profile on the parallel plot. So I can pick some green or red profiles and see if there are any patterns in the data. So that's the first platform I wanted to mention, which is the graph builder. And by the way, I didn't show this, but every output has the option to save it. Yeah, and then you have it as a script, like these scripts here, and you can just get it back and run it again, and you get the same output. Yeah, so saving this would be when you're done, you go down on the top red triangle on the context menu, go down, and then save this to the data table. Yeah, and then we have this saved. Yeah, so what I could here is, because there's an option mentioned, I could use a data filter. Maybe not a bad idea. So if you want to filter the data, I can add a local data filter just to this graph. And then maybe we can filter on base supplier. Yeah, and I can look at this supplier and this supplier separately. Yeah, I can also add another filter condition, maybe water content. Yeah, and this is continuous, so I have a slider. Yeah, and then I can look at all the batches with maybe low water content or medium water content or high water content. Yeah, so I hope you see the interactivity you have here for subsetting the data, filtering the data, and visualizing the data. That's interactive graphing, graph builder. So there's another menu called Analyze, and there are more statistical analyses platforms. And there are many, so maybe on the first look, it's a bit overwhelming because there are also many modeling tools and machine learning and multivariate analysis. But what I want to show you to get started is distribution is univariate statistics. Yeah, fit y by x, 1y, 1x. This is about bivariate statistics. And then fit model is for modeling, building a multivariate model. Yeah, so just taking these 3 analysis platforms, and that's maybe also enough you need for a first statistics course or even two courses on introductory statistics. So how does this work? So this is a bit different. You start it, you get a launch window, and then you have all your variables on the left. And now we pick the variable we want to analyze. As I said, this is univariate, so it means we just need a single variable and we can click OK and analyze. And as you see here, because the yield has a spec limit saved, we can also look into the process capability. So how capable is our process regarding the specification? So that's a process quality topic you may want to consider or not yet. And this is the standard distribution output. So we have quantiles, we have summary statistics. Yeah, and this is the yield histogram. I can also turn it around. And by default, we also see a box plot. We see some extremely low yield values, which could be outliers, yeah, but maybe not. So looking at this distribution, yeah, and then a tip today, what you should remember are the red triangles. The red triangles are your best friends because there you get all the options, statistical tests and everything, which make sense in this situation, in this context. Yeah, so here we have one numeric variable, a continuous variable. So we see a histogram and all of this. So here maybe it makes sense to look into normality. Yeah, so do we have a normal distribution in this column? So you can look at a normal quantile plot. Just switch it on and off. If you ask, hey, which is the best distribution fitting these data? Yeah, red triangle. And then do a continuous fit. So fit all the continuous distributions, maybe all of these to the data, fit all. And then we see a ranking. And a normal two mixture would be best. I just compare it with a normal. Normal is second best. So I just choose the normal distribution. And doing this, we get more information down here. So these are all the details about the fitted normal distribution. Yeah, with the parameters mu and sigma, and another red triangle, step by step. So if you ask now, how good is this fit of the normal distribution, the fit to these data? Red triangle, and do a goodness of fit test. Boom. Yeah, and then JMP runs this test. These are p-values. Yeah, and they are black. They don't have a star. They are not special, so it's not significant. And how to interpret this? Yeah, one thing is you can point to a number like a p-value, and then JMP gives you a tooltip helping you to interpret a statistic. Or you look here, the null hypothesis is the data is from a normal distribution. Small p-values would reject this. And they are not really small, not small enough, not lower than 0.05. Yeah, so red triangles and then step by step. Look for red triangles because there you can dig deeper, run a test, add more information to your output. That's distribution, univariate analysis. And as I said, top red triangle, you can save everything as a script to the data table. So I close this, and then I run this script here, the second distribution analysis. And this is an example, just the histograms and the bar charts, but for 12 variables. Yeah, and these are our two responses. Yeah, so we have the categorical response, and a batch can be rejected or accepted. And everything is interactive. So just choosing the rejected, the bad batches, what do we see? Oh, we see that the larger vessel size is maybe not a good choice because here the portion of rejected batches is 11 out of 34. For the small vessel size, we only have one rejected batch, yeah, out of 32. So the smaller vessel size is probably better. Yeah, what else? Carbamate amount. So here you see, oh, low carbamate amount, maybe not a good idea. So if I choose the higher carbamate
Bros,
amount batches,
what is the problem of
all of them are
you've been saying today since it's 2 weeks, so Oga?
nothing rejected.
Eh?
There's
And then I approve it.
some.
And then I approve it. So you buy tomorrow,
Maybe-
today now.
Maybe Olavala can help unmute.
You've been hearing this tomorrow. Our food is spoiling.
Jordan,
We can't
please
drink water
mute,
again.
mute your mic.
We can't drink water again now. Water is not cold. Okay, let's tomorrow come.
Mr. Tokwe, please
Okay,
mute your mic.
So
hello.
Actually, you can mute him.
Hello.
Jordan.
look at
You can mute
univariate
him.
analysis.
Hello. Good day. I'm
Let's
fine.
Hello, good day. I also wish a good day. You are unmuted, please.
I'm fine.
Okay. Okay, so next level. We are just exploring the data set, running some basic analyses. And the next level would be looking at relationships between two variables, bivariate. And that's the second platform on the Analyze menu, fit Y by X. That's the name. And you just launch it here, and then you assign two variables. You set one Y and one X, and then you click OK. So maybe let's do this. One example, yield by carbamate amount. You remember we already saw this in Graph Builder. This is continuous by continuous. Yeah? The blue icon means this is a continuous scale. It can be interval or ratio scaling, but numbers and on a continuous scale. So this would enter a bivariate analysis, a so-called bivariate, and that's a simple linear regression. In JMP, you just set the variables, and having the types set correctly, JMP knows what type of analysis to apply. In this case, it's a scatter plot you get in the first place. And then looking at the red triangle, again, the context menu. So this is about fitting polynomials or robust fitting. We can also fit a line. That's the simple linear regression. A very simple model. We get a main output here. We get the line, the red line. We see the positive slope. And then all the details for this fit down here. So here we see the equation for that line. Yeah, and here's another red triangle. So we could add a confidence curve. Yeah, maybe also some shading for the fit. Yeah, a confidence band for this fit. Yeah, and many other settings you have here. You can look at residuals and red triangle to dig deeper. Yeah, so that's one bivariate analysis. Here's a second one, doing the same, fit y by x. I just run the script. What's different here? We have again yield on the y-axis, but we have a categorical variable on the x-axis. So here we get the dots, the data points in three groups, yeah, by vessel size. And that's the magic because it's the same platform, fit y by x, but if you open the red triangle, you have a total different tool set because this is about analysis of variance and yeah, so different techniques. It's not about linear regression anymore because we are looking at groups, yeah, and then running an analysis of variance. You get this table, we get the overall p-value telling us, there are some differences between, at least between two groups. So this is significant. And then you ask, okay, which groups are different? You can also compare the means. Yeah, it's quite easy to see in this case, but you can also run a comparison of the means between groups. And then if the colors are different, there are significant differences regarding the means between these groups. And again, all the details, you always get all the details down here, all the statistics and red triangles, more options. But we already see this from the colored circles. And we had the local data filter earlier on the graph builder. If you remember, we had the data filter to subset the data, and the filter filters on rows. So we can subset the data points we have. Yeah. Another exploratory tool is the column switcher. So that means we can also pick a certain column and replace one column, one variable by another variable. Yeah, so just to reuse this analysis, and now we are looking at vessel size. Yeah, and we are swapping the vessel size out and another variable in. And now we can walk through all these categorical variables, yeah, and see if there are differences or not. So here, these two groups are not significantly different regarding their two means. Yeah, and if there are two groups, JMP already runs a pool t-test. So JMP knows which tests to apply in certain situations. So that's another example for a fit y by x. So we saw this here, continuous by continuous. We saw this case, continuous by categorical. And then there's also logistic regression and contingency tables and mosaic plots, chi-square testing for a categorical by categorical case. So all of these are the result of this from the same platform, the bivariate analysis. And then finally, and that already leads us to the next part 2, multivariate analysis and modeling. And we will also see another example. But to build a model using these data. So we are asking ourselves, how should we set the categorical and the continuous settings in our data set? So these process settings to get highest yield. So what are the best process settings? And the previous question is typically, which of these settings have an effect on yield? Maybe not all of them are important to monitor and to change and to control. Maybe just a few. But for these few, maybe we also have higher order effects. Maybe there's something quadratic or cubic ongoing or an interaction. So these are the questions we are facing now building a model. And we can look at this also after the break and during part 2. I just run the script which comes with the data set. Yeah, so if you open this journal in JMP, you can open the same data set, which is this one here, and the data set will have all these stored analyses you can just run by clicking the green triangle. Yeah, and then you would also get here without doing anything else in the software. Yeah, and what do we see here? We see again a visual output first. Yeah, so JMP tries to summarize and highlight some results visually in the first place for any analysis. Yeah, and here this output is an actual by predicted plot. Yeah, so these are the measured yield values, and they are visualized against the predicted yield values by this model. Yeah, and we will check what type of model are we looking at. We can do some reverse engineering because this is already the output, the result. It could be a final result. How did we build the model? So you can also open the red triangle. So that's where you also save something as a script. But you can also ask under redo, start this analysis again. Yeah, and that's relaunch this analysis and show me how this model was built. And that was the starting point for this output. The starting point was using fit model. So this platform, yeah, it's on the analyze menu, fit model. So you get this launch dialog. You set my response, the Y is yield. Yeah, and then you set all the model effects. That's, of course, the interesting part, yeah, where you have to maybe know what are the important settings or predictors. And here we have 5. In this model, we just have 5 main effects. Yeah, vessel size, we already saw earlier, also in Graph Builder, that the vessel size matters for yield. Yeah, we also saw that there's an influence of carbamate amount. And there are some other main effects. And then we have carbamate amount times carbamate amount. That's a product for a quadratic effect. And then we also have 2 interactions, so synergistic effects between carbamate amount reaction temperature and the temperature and base assay. And then there are many ways to build the model. JMP picks the best standard way for these settings, these variables, and that's standard least squares. That's multiple regression. Yeah. So just by clicking run, you get to a similar output like this, and then you open and close sections, and you use the red triangle to add some information. So doing this is the summary of what's important for yield. The first place in this model is vessel size. The second place is base assay and so on. Here's the quadratic term, which is significant. That's maybe interesting. Here is an interaction, which is significant as well. So the terms in our model were already carefully selected because all of them come out as being significant. So we were all set to build a useful model. That's the ranking of our model effects. How to interpret and how to use a model, that's a different story. And for that, you typically use the profiler in JMP. So the profiler is what we see here. So these are sections through the response surface. The response surface for a multivariate problem is a multivariate surface. You typically cannot visualize anymore, but here we have traces for every factor. So this is our response. And then here we have the factors, vessel size, carbamate amount, and so on. And the red numbers are the current settings. And for a process like this, with a vessel size at the medium size, this carbamate amount and this base assay, the model predicts a yield of 81%, and the blue numbers are the 95% limits for the confidence interval for the yield we would expect. Because this red number, that's the average, of course, the mean yield we would expect, and there will be some variation, and the variation is what you have here as a confidence interval. Now the point, this is interactive again. So we can change the vessel size to the lower one, and as we see here, the yield goes up, because the lower vessel size is better than the medium and especially better than the higher vessel size. We see the quadratic influence of carbamate amount, this curved relationship. And by changing some factors, we can also see the interactions. So changing the base assay, look at the reaction temperature. And this shows us the interaction between these two effects. So if you think, let's get a process which is robust against reaction temperature. So you could set a base assay like this, and then the temperature doesn't really matter anymore because we have a flat response curve here. So you learn about the model, you can better understand the model, you can play with the settings, you can also see higher model effects, and finally, you can also ask for the best settings down here. And guess what? It's the red triangle again. And then optimization and desirability, and then I maximize the desirability. What is desirability? It's where we want to be, and that's the setting I showed you at the beginning. We want to maximize the yield. So where on our response surface will we see the highest yield? Yeah, and I choose maximize desirability, and then we get to this process configuration. So that would be the solution from this model. Yeah, we are just looking at one model, a single model, a simple model, hopefully a useful model. And from that model, the solution suggests to use the small vessel size, this carbamate amount, the maximum water content and temperature, and the lowest base assay. And this would promise a yield of 92%. Yeah, and looking at the lower limit of the confidence interval, it's not below 80%. So we are maybe on the safe side that we won't see any yields below 80 anymore implementing these settings. Okay, I think we maybe almost ready to take a short break and questions. The final thing I wanted to show here, because this is a model, we could also look at the model by looking at the equation. That's the equation, which can also be saved as a formula. Yeah, this is the equation, how to calculate the expected yield based on our process settings. Yeah, so that's the model, but using JMP, you typically don't look at the equation or all the detailed parameters. You look at the profiler. And what we could do is we can save the prediction formula, so to also apply this to other batches in the future. Yeah, we can also publish this model or the prediction formula, and this allows us to take the model and export the model as C code or Python code or SQL code, or so in different languages. And if you want to have this model ready to deploy in Python, you can just do this. Yeah, so maybe prototyping a model and then getting the model and deployed in a different environment is quite easy as well. Okay, so that's maybe enough for the first part. We can now have some questions, if there are some questions, or also a bio break. And then during the second part, I also want to show you some more higher end capabilities and features in JMP, because all of this was quite basic. So also give you an idea about the other end of the scale for analytics. And I also want to mention some resources and support options. That's the plan, at least. So if we have any questions right now, I'm happy to answer any question or a question from yourself or Wale, or any feedback. Also appreciated, of course. So summarizing this, what we did so far, no programming, no scripting, just clicking and drag and drop, quite easy. Everything is very visual and interactive, and it is progressive. So that means you launch an analysis and then you have all the tests and tools and capabilities on the red triangles where you can proceed. So you get a starting point, a first report, you get some answers, but you also get another question. And then address the next question, the next question. So it's really a progressive workflow which is supported by our software. And you don't have to configure everything up front. Maybe SPSS, another maybe a similar package, but there you have to configure everything at the beginning. You get one result, and if you want to change anything, you have to go back to the start. In JMP, it's really step by step using the red triangles. Any question?
Good day, everyone.
Hello.
Okay, I wanted to ask just two questions.
Mhm.
I'm very new in data analytics, and that's why I'm here to learn how to work with JMP and other tools for data analytics. So my question is, this data that I'm seeing on the screen by the right,
Mhm.
how did it get into the software? Is it that JMP can be connected to database directly, or is it an Excel file that was imported into JMP, or the source data, how you got into this software? That's one. Then my other question is going to be, is JMP, does it only analyze structured data? Does it also work for unstructured data like images, videos, and other unstructured data?
Cool. Excellent questions, Victor. Thanks for asking. I think all the answers are yes, you can. So for importing data, we could spend a lot of time on importing data. So theoretically, you can start on a green field. So start with a new data table, and that's then you can enter the data yourself and configure the columns and everything. But that's not the way to do it typically. So you may have the data somewhere, and then you just open. So you choose File, Open, and then you can open an Excel spreadsheet. So it helps if the data is already structured in a similar way like this. But you can point the import wizard to the data on your spreadsheet. You can also concatenate multiple worksheets, and then you get a preview. At the end, you say, yeah, let's go. You click import, and then all the Excel data is imported into a JMP table. Or file, internet open. You load data from an internet, from a web page. Or you build a data a query yourself using a query builder. Or you load data from an Amazon cloud, and we also have a marketplace where you find data connectors for specific databases and so on. So getting the data into JMP, you have a lot of options, both from files, from databases, or any other environments and systems you probably can think about. But then you may need to add an add-on to the standard software. It's maybe not out of the box, but there are special add-ons for these use cases. And structured data, yes, this is tabular data. Tabular data we just looked at, but JMP also has an option for text analytics, text explorer, so you can have text documents, and then you can have a topic analysis and clustering and sentiment analysis. So really text analytics. And that's unstructured text data you could have in your table. And you can also analyze images and do some deep learning, but then you may also leverage Python packages. So for instance, in our marketplace, let me just show you this one. You will get all the links. I will send you the links later on. In our marketplace, these are free add-ons to our software. Yeah, and here we have one add-on is for deep learning, and that's this one here, Torch Deep Learning for Jump Pro. So this leverages the Python PyTorch package. Yeah, and by the way, you don't have to install Python if you don't use Python, because with every jump installation, you get Python automatically embedded as the jump install or by the jump install. And using this, you can also, analyze images and curves and functions and other data formats.
Thanks, Volker.
For curved data, so under specialized modeling, there's also something called Functional Data Explorer for functional data analysis, like spectral data or curves or anything. And that's another very powerful platform with pre-processing and dynamic time warping and all these tools built in. JMP is not made for the statistician. It's a statistical package, but it's built for the applied statistician, for the scientist, for a manager, for an engineer who is more interested in solving a problem than developing a specific statistical method or anything. So then they typically use R or other programming environments. JMP is really practical and should have everything you need to solve a problem. And the problems are also typical problems in industry. Yeah, so that also means that JMP methodology is quite relevant to students because these are the workflows and methods which are also applied in industry to solve real-world problems. You also mentioned that you're not a statistician like many others, maybe all others. So for that, this journal here you will get later on has a section about help and where can you learn more. Yeah, I would just suggest that you look at this section and then follow the links. So you get to our online documentation, but you also get to courses. Yeah, and information, for instance, documentation. Yeah, this one here. This is called the Statistics Knowledge Portal. Yeah, and if you're interested in predictive modeling or other topics, yeah, so here you can really read about basic concepts. So this is really, basic, to the point, not too much terminology and too much voodoo, really practical, what you should know about also quality, hypothesis testing, linear models. multiple linear regression. Easy examples, just a few formulas, but very easy to understand. And if you want to learn and use maybe a short course, this is a MOOC. It's an open, free online course. 7 different modules. And if you are interested in, let's say, predictive modeling, so this course would take you up to 4 hours, and then you would learn about these concepts. So these courses are really very short videos, interesting demos, some practical exercises and quizzes. So it's also really interactive and engaging. And this program, this course program, teaches all the methods and capabilities which are considered as relevant by our customers. So all of this is really relevant in industry because we did a survey with maybe more than 200 of our customers, and we asked them, what's important to solve your problems? And then we put everything into these courses, these modules here. So really relevant concepts and methods. And this is called statistical thinking for industrial problem solving. And that's the point in JMP. It's not about the tools and where to click and the menus and where to find things and programming. This is really about statistical thinking. That's the main point. And the barrier, the technical barrier between the brain, which is thinking, the user, and the data should be as low as possible. And JMP is really analysis at the speed of thought. So you can just next step, next step, next step, without thinking about menus and commands and syntax and everything. It should be really intuitive, accessible, inspiring, and tell you something about your data. Okay, with that said, let me spend some time also on some more advanced techniques. That's especially, or that's more on modeling, predictive modeling, maybe or some machine learning. I would like to show you. If there's no other question, of course, maybe I wait 10 seconds if there is a question during that time. Yes, yes, please.
Volker, please go ahead, Volker. Thank you so much.
Okay. Okay, thanks. So there's a second journal. So I took this from different courses and workshops. There's also much more information in this journal. You can also browse for yourself different topics. We cannot look into everything today, of course. But there's a data set, a new data set, and this is about patient data. So now it's more medical, less chemical. And here it's about diabetes. And we have 442 patients and that many rows in this data set. We have 15 variables, 15 columns. And this is a continuous response. So a patient came in, there was a base measurement using blood measurements and everything. And then 1 year later, the progression of the disease has been measured. So this progression is the progression of diabetes over the last year. Yeah, and the higher this is, the more critical, the more the diabetes developed. Yeah, and there's again a binary version of this response. So we have the low and the high progression also into classes. And then we have patient data. So we know the ages, we know the body mass index, blood pressure, and cholesterol, and sex, female and male. Was there a diabetes case in the same family before? No and yes. So that's the information we have here. And now the question is, what are the patient data? What we can measure from a new patient tells us about how the diabetes may develop over the next year. So that's what we want to understand and what we want to model using this data set. And there are some scripts which are also stored here in two parts. You can explore yourself. So here just run them. And here we see the progression by physical activity. And you can see if this makes a difference or not. Just looking at a single predictor. But of course, this is a multivariate problem. You could start with graph builder as well. So here we see the progression of the disease by body mass index, and we see clearly a positive relationship for different blood pressure groups. So again, exploratory and basic, that's what I want to skip right now. But what you would typically do if you get access to a new data set, you would start with graph builder, you would start with distribution fit y by x, the basic ones. And then after learning what matters, what are the interesting predictors, so the drivers for the progression of this disease, you are maybe better informed to build a model. And we could build a full model like this. So this will be the result. A full model, that means all our predictors and all the two-factor interactions. Oops, not that one, the other one. So the full model. And that's the output, a multiple regression model for all these effects. Yeah, you see, this is maybe crazy. And is it crazy? Yeah. Go down and look at the profiler, and then we see, yes, it is crazy because the confidence bands are so broad that we don't really learn anything. It could be, so here we see a curve like this, but it could also be this, or it could be this. We don't know. Yeah, so there's so much uncertainty. The standard errors of our estimated parameters are so huge that we don't really learn anything from this. So this is crazy. So what you do, yeah, you limit the model. Maybe you do a stepwise regression or something to have a simplified model like this. Yeah, so here you see we have less effects. This is the full list. And we see that LTG, this has the highest impact. Highest impact means lowest p-value. And this is sorted by p-value, and H is not significant as a main effect. Yeah, look at this p-value, not significant at all. But this symbol points into this direction because H is also part of this interaction, which is significant. So some best practice is if the child is active, also keep the parents in the model. Yeah, I could remove it, yeah, but we can also keep it in the model. That's maybe a good idea. So this is the summary of our effects. We can also look at a summary of the fit. So the model performance overall. And here, for instance, we see an R squared of 55%. That's the R squared adjusted, which is recommended if you want to compare different models of different complexity. Maybe take this one here, 55%. Okay, good to know. And then this is the profiler, which looks much better. Yeah, so these standard errors are much smaller. So that's good. We could also check the variance inflation factor. So this is the inflation of the standard error because the predictors are correlated. Yeah, and that's an interesting question. Are our predictors correlated? And if you have high correlation, you will get high standard errors and you will get these crazy confidence bands. By the way, there's also a um, multivariate analysis. So I can take the continuous predictors in here to check the multicollinearity. Do we have correlation between our predictors? And then these are the coefficients here. If it's really red, really blue, that's a bad thing, not on the diagonal, but all the other numbers. And here we see a scatter plot matrix. And this can be also used. Maybe I can have ellipses and shaded ellipses, not the points. And now if we see a small ellipsis, then there is a high correlation. So if it goes up, it's positively correlated. This is negatively correlated. I can also add a heat map. So if it's really red like this, it's highly positively correlated. So that's this one here, and so on and so on. So that would be a preparation step you should check first. Otherwise, you will see high variance inflation factors, maybe above 5 or 10, what's bad, or you would see very broad confidence bands. This is much better. So this is probably a good, useful model. Yeah, we can really learn from. And again, you can play with all these settings. It's not a process. It's nothing we can set because these are patient profiles. So nothing we can really set. But we see that, so for these other measurements, a female would have a slightly higher progression than a male patient. And if there would be no very low physical activity, so no sports at all, it's maybe it's a minor influence, but a minor increase in the progression. And then do the same thing here. Desirability, yeah, desirability function. We can also just maximize the desirability. Let me remove the functions. Again, we don't need them. So where are our curves? They are here. So this, now I maximized. Yeah, it's not desired, of course. This is worst case. So that's the most critical patient, which would have the highest expected progression of the disease. And that's for a young patient, yeah, with the highest body mass index, with the highest blood pressure. So all of these are not good signs because they would indicate a high progression of the disease, and so on and so on. So here, if there was a case in the family before, it also increases the progression slightly, and so on. So that's one model you could use. The R square is 57%. I think it's maybe Chris, Bob, no, Bobby, not Chris.
Yeah,
Or
you
maybe
can mute him. You are the host. Volker, you can mute him.
Okay. So that was a model already prepared well, because I can just run it again. It's this, the last script here, this one. How was this built? Again, relaunch this analysis, what I showed you before. Yeah, and this was already carefully selected when building the model. Yeah, but how can you know? How can you know which interactions to have on the model? Yeah, and as we saw earlier, putting everything into the model it's too much. Maybe you don't have enough degrees of freedom to estimate everything. But what's important? Yeah, and what's relevant? So how to get there? One example could be this predictor screening. So that's quite easy. I show you how to do this. This is screening, predictor screening. I just say, I'm interested in the progression of the disease, and I take all the predictors, and please tell me which are the important ones. I click OK, and that's the result. Yeah, this uses a random forest behind the scenes, and 100 forests used, 100 trees used in this forest this way. Yeah, and then LTG is most important, and then body mass index. And here the family history is least informative about the progression. So that's predictor screening, one thing. Another option is stepwise regression, and this starts like this. So that's the launch to launch a stepwise regression. So add model effect by model effect to our model step by step, and not using everything else. So we use a forward regression starting with an empty model, and clicking step adds one effect. And this effect is a two-factor interaction. So we get these two main effects and the interaction added from the first step, and then another step, and JMP always checks which is increasing the model performance in the best way, depending on measures you can also configure here. Or I just go and then everything is done until we see the minimum BIC, Bayesian information criteria. And then I could choose, okay, let's make this model. And then these are the effects, starting with everything with an empty model and then step by step by step. And the stepwise regression stopped here to add more terms to the model because this was the best BIC, the lowest BIC model. Yeah, so that's a stepwise regression. We could also use panelized regression like lasso or elastic net and these techniques. So here we see that we have this normal. Normal means the distribution of our response is a normal distribution. We used a lasso for the estimation of the parameters. And this is how we stopped building the model. We used AIC validation. And that's what we see here. And we can also do this interactively. So I could start on the left. Again, nothing in the model yet. And then adding the first two parameters. And then we see BMI and LTG have been added. And then adding a third parameter, which is the blood pressure. And we are improving. So the AIC still goes down, goes down, goes down. And then adding more and more. And then at some point, adding more terms to our model does not improve the model anymore. So the solution is really at a minimum number of model terms where we have an acceptable a minimum AIC corrected. That's the validation part of this story. And this would be the solution. And then there's much more you can do here. You can specify the distribution. You can specify the estimation technique, lasso, or also some forward, backward techniques, elastic net. And then how to validate. And then you get here, and then you can build another model, another model, another model using the same platform here. And then at the end, you may have a comparison with all the models you built so far. So here there's one using lasso, one using the best subset technique, and one using elastic net. And then what's the best one? Maybe you look at AIC corrected and then pick the one with the lowest AIC. Or you also look at the parameters, number of parameters, the complexity of the model. But that's nice. So this one here, it has the smallest number of parameters and also the lowest AIC. That's maybe a good deal. And I can switch all the others off, and then that's maybe the selected one, and then you can look at the details here. This is a platform generalized regression. So this combines advanced techniques, including generalized regression using other distributions, including panelized regression like lasso, elastic net, or rich regression and others. And then finally, probably finally, what I want to show is maybe you know what to put into the model using the exploratory analysis, some basic modeling. We already learned which are the important effects. What's going on in this system here in medicine with diabetes. But now we are asking, okay, there are many different ways to model these data. So what is the best way, the best model for our problem, for our data? And there's another platform in analyze and then predictive modeling and then under model screening. Yeah, so this can be used. I just run this script. So this checks all the models, almost all, the selected, or let's say many models, different ways to build a model in JMP. Here using the binary predictor, this one, binary low or high. So now we are modeling the binary outcome, but using all the information, all the patient information we have. Let me run this. So this has to think for a few seconds at least. And this is the result from the model screening already. Let me show you the starting point. Relaunch this. How was this started? This was the starting point. Yeah, when you launch it from the menu, everything is empty. So then you would say, okay, this is our response, the binary outcome. These are our factors. So these are all the predictors, all the patient measurements we have. And we have a validation column to validate. So that's about avoiding overfitting and doing some validation. What's a good idea? Of course, if you want to build predictive models, if you want to apply the model on new data in the future, do some validation. If you don't have a validation column, you can also do k-fold cross-validation or use some other built-in techniques. The validation column, by the way, is this one here. It splits our patients into two groups. Some patients are in the training group to build the model, to train the model, and then some other patients are in the validation group to pick the best model. So to say, okay, now stop training, stop with training, otherwise we would overfit the model. So that's a nice way to control overfitting. And then clicking OK would use all these modeling techniques, a decision tree, a forest, a boosted tree, k-nearest neighbors, and so on and so on, support vector machines, also some machine learning models. And the question will be, for this problem, which modeling technique is the best? Of course, you can run all of them individually and you have to start them and configure them, but it can be automated using the model screening. And then this would be the result. It's sorted by R square. We just go to the validation data, because that's what's more interesting, not the training results. So for the validation data, which model has the lowest misclassification rate? If that's the selection criterion, the winner would be a neural boosted model. And you also see the performance of the other models tested. You can also use other criteria. And then if you think, okay, yeah, neural boosted, let's build that model. And then you choose it and you run it. And then you have the neural boosted model. And this gives us this misclassification rate on the validation portion. Yeah, and of course, we could also add a profiler. So typically, after every modeling step, you also add the profiler, or you save the model and then use a standalone profiler to visualize the model and interact with the model. And here we have some details. So because this is a binary outcome, we could set the decision threshold, and by default, it's set to a midpoint, 50%. And then with this threshold, you see also so these are the false positives and also the false negatives. And then you can change the threshold and you see how this affects the error distribution. Type 1 error, type 2 error. Yeah, it depends on the threshold, of course. We can also just look at the neural boosted, the selected model, and then you have the misclassification rate. And then we can set for these errors, we can maybe choose a midpoint, and then we see this could be a suggested threshold to get this error distribution down here. Yeah, with all these measurements and metrics are also available, of course. So that's the model screening, an automated way to check different ways building models. And finally, some modeling techniques are not coming with a standard product out of the box. They can be added using add-ins from the marketplace I showed you earlier. And then add-ins show up on the add-ins menu. And here is an XGBoost model installed as an add-in. And you can use it as another jump platform. It just comes as an add-in. And here maybe progression, and we have all the predictors. And then I want to do validation, and then click OK. And then, okay, let's auto-tune these parameters to find the best settings for our models. And then let's go, and that's the result. Yeah, again, interactive, visual. And here we see an R squared on the validation data of 43%, not bad. And there's also the deep learning add-in, which uses PyTorch and Python functionality, which is just available under the hood if you don't have Python installed yourself. And that's for image data and as we discussed earlier, also for other data. There are many resources available. I already mentioned the courses and the knowledge portal, but we also have a learning library like this. You will get the links. So these are getting started guides. For any of these methods, if you want to know how can I do a non-parametric test in JUMP, or how can I fit a nonlinear curve, or how can I do factor analysis, just go here and then you get a short video and a single page, one PDF page telling you where it is and how to start. That's one option, the learning library for getting started. How can I do this or this in JUMP? And another add-in I would like to recommend is the LearnBot. On the marketplace, if you look for LearnBot, here it is. So this is a chat bot. So it's like an embedded tutor who helps you using Jump, but also recommends some next steps and how to move on. Yeah, and just download the LearnBot, double click, and it will show up here as a first option on the help menu. Yeah, and then you can, okay, let's ask the LearnBot, how can I, not IO, how can I build a regression model? And then we get, oops, we get the output here. So where to start, and how to do this, how to interpret the results. And then in the end, you always have some recommendations for further learning, but also be careful. This is generated by AI and it may have errors. But I think it's quite useful. So we could also ask, what about predictive modeling? And then it also mentions, also consider validation and build a validation column. So here, validate the model. So what becomes important, especially for predictive modeling. And you can ask any question you are interested in, and you will get some tips and pointers and best practices. That's the LearnBot. And final thing, I am also available as a human agent. So if you have questions, if you need help, please also contact me at any time. When you start to explore your data sets, and that's maybe the next step, not just look at the sample data. There are also hundreds of data sets coming with the software. So food and nutrition. So really many data sets you get with the software. Most of them have scripts, so you have some stored analyses you can look at. But more exciting, use your data and then import the data, prepare it, clean it up, and analyze. And then also visualize the results and tell the story. And I hope you also saw that JMP can be used to tell the story and visualize the outcome. If you have any questions at that point, please let me know, and I'm always happy to help. I'm available on LinkedIn, but it's also this email address here. Oops, this email address. volker.kraft@jmp.com. But I will also send an email to Ola Walef with the journals, the data, and some links and further information. And then you are happy to explore it. Academics should get the academic license quite easily at jump.com/student. So this starts here, jump.com/student, and then get JMP for free. There's also an FAQ, and this is a 1-year license which can be renewed. So you will be checked again if you're still academic after a year, and then you can renew the license and continue to use it for free. If you are not academic, talk to Olawale, and there's another option, as I mentioned earlier, for continuing education. If you are on the course for learning purposes, we can also share license codes so that you don't need to validate to be academic. You get a bypass code, and then you can also get a license. Time is almost over, just a few minutes left, but I'm not on a rush. I have some. So if you have questions, if you also have feedback, but I also understand if you want to think about it first, if you want to try it on your own, if you want to discuss it in a group, in a class, what you think about it. And if you would be interested in a follow-up seminar, maybe it would be more a themed seminar on a certain topic, maybe building predictive models or process quality tools or experimentation or data visualization, exploratory analysis, or data prep and cleaning, or so there are different topics we could start with.
Yeah.
If there is
Yeah.
a topic like this you would like to
Yeah.
use Jump for, we could also have a practical, more hands-on session looking into a specific application of our software. Today it was really broad. It was maybe a lot you saw today. I just hope you are a bit inspired and curious to try it yourself. Yeah. And I'm happy to do any follow-up workshop if you will be interested.
Thank you so much, Volker, for this exhaustive uh, lecture. This is really, really great. Let's appreciate him. Thank you for this lecture.
I don't see the chat right now. I don't see.
Can we take one or two questions?
Yeah.
I don't think there are questions on the chat.
Oh, here's the chat. Okay.
Yeah, they're just appreciating the lecture. Yeah. So
Great.
we,
You're welcome. It's a
yeah,
pleasure, of course.
thank you so much, Volker. Yeah.
Thank
So
you.
we will talk more
Mhm.
about subsequent lectures for the
Yeah.
class.
You will definitely receive an email from me with
Yes,
information I mentioned, and then at some point, let me know what you think and
all right.
if you want to proceed, and if yes, how, what
Yeah,
could be interesting as a next step.
yes, no problem.
Okay, cool.
Yes. Okay. Thank you.
Thank you
Thank
all
you.
for joining. Bye-bye.
Thank you. Thank you,
Nice
Volker.
day.
Thank you, Volker. Bye. See you later. Thanks, Volker.
Thank you.
Thank you. Bye-bye.